guys, happy Tuesday. Hope you had a fabulous Labor Day weekend and got to relax a little bit on those 3 days off. No, I sure did. Had a lot of stuff with the family, so hopefully you guys had a great Labor Day weekend. So going back to last Friday, we did a couple cool things in here. Remember, we lit some things on fire, showing you different colors from different elements. So we had a couple of videos. Actually, it's two videos of the same thing we did, but just from different perspectives. So I'm going to show that to you guys here. So let me pull that up. Oops. I guess I had some stuff from the pep assembly too. So there's one of our pictures. I'm looking very good with my mustache there, a little bigger there, a bigger chin there, a little square chin there. I also had some other stuff on here. Some of you guys dancing out there during the pep assembly. So yeah, overall, very fun pep assembly. I saw a lot of you guys out there. I think some of you guys got into the Snapchat, so I posted some of those pictures on our Twitter account out there. If you want your picture, if I got a picture of you, I could send it to your phones too during class. Just let me know. So those are some pictures from our pep assembly, and here's some video from our class yesterday. I mean, Friday. This is from a different perspective.
Oh, wait a minute, I'm gonna look at it. Is it over?
All right, so that was magnesium. So some classes, I don't know if we got the magnesium in all the classes, but right there we lit the magnesium. It was super, super bright, and we told you guys not to look at it, kind of cover your eyes. And some of you guys took great videos of those. So again, with those, if you want, post those to at Germosel, our Twitter feed, or on Instagram, Germosel. So get those out there. We love to see everything you guys take in classroom. And actually this week we'll start giving you guys a little extra credit bonus assignments when you post to our Twitter feed or Instagram feed. So today, we're gonna still continue with color, with the stars here and what that color actually tells us. And we're gonna be talking about something, or this relates to what we're going to be talking about, the green flash. I'll stop talking. This is from the Pirates of the Caribbean, and I'll let you guys watch here for a little bit.
No one said anything about coal. I'm sure there must be good reason for our suffering. Why don't that Obey woman just bring Jack back the same way she brought back Barbosa?
Because Barbosa was only dead. Jack Sparrow is taken, body and soul, to a place not of death, but punishment. The worst fate a person can bring upon himself. Stretching on forever. That's what awaits at Davy Jones' locker.
No. I knew there was a good reason. Nothing here is said. These can't be as accurate as modern charts. No. But it leads to more places. Over the edge. Over again. Somebody says, flash of green. You care to interpret, Captain Barbosa? Ever gazed upon the green flash, Master Gibbs? I reckon I see my fair share. Happens on rare occasion. The last glimpse of sunset, a green flash shoots up into the sky. Some go their whole lives without ever seeing it. Some claim to have seen it who ain't. And some say it signals when a soul comes back to this world from the dead. Sorry. Trust me, young Master Tanner. It's not getting to the land of the dead that's the problem.
So right there, we're talking about the green flash, and we're going to actually look into that today and what causes that green flash. Is it this folklore, a pirate story, or does it really, really happen? So we're actually going to look into that today with an investigation. We're going to use some prisms in here and why the green flash might occur. And also we're going to come back to this video at the end of class and see, is it really true that a green flash occurs, and why does a green flash occur when the sun sets? So going back, and I don't think I talked about this, this was our objective for today. It says, I will be able to explain how color indicates the chemical composition of stars with 80% accuracy. So again, we are going to get back into colors again, and we want to use what we learned today to talk about the stars and what those certain colors mean with the stars. Remember we talked about Roy G. Biv, and I'm going to get my little whiteboard up there. Roy G. Biv. So let's use it. So Roy G. Biv. So we're going to be looking into investigating Roy G. Biv a little bit more today and see what happens with our prisms and white light, and see if you can relate that back to the green flash there that's talking about in the Pirates of the Caribbean. And I have another video that you'll see in this video that I'm doing. We're just going to pause it and then check it out to see what creates that green flash. So we're going to erase our board here. I'm going to undo our Roy G. Biv, get that out of here. We're going to pause this video, and when you come back, we'll have that video talking about the green flash.
The mythical green flash during a sunset. It was first made popular by Jules Verne in an 1882 novel, and it's still leaking into pop culture through an occasional pirate movie sequel. Except it's not actually a myth. I know, it's weird. Usually we're debunking things people think are true, not the other way around. But the green flash is a real optical phenomenon, and it doesn't just happen right after the sun sets. You can see it right before sunrise, too. You can see it from any altitude and from anywhere in the world, but you have to have the right conditions. You might think that the Earth's air is pretty uniform, minus the occasional puffy cloud or two, but there are a bunch of invisible layers in the atmosphere, each with slightly different temperatures and densities. As sunlight travels from one layer to another, the light refracts or bends just a teeny tiny bit. It's the same principle that makes your straw look like it's bent below the water in your glass, but the amount of refraction depends on the wavelength and therefore the color of the light. So the different colors end up separating out from the white sunlight that enters the atmosphere. The most obvious way to see this separation is in a rainbow, although that comes from a much more dramatic change in density, from air to water droplet, so it's a much more obvious effect. And the shorter the wavelength, the more light is refracted. Bluer light has a shorter wavelength, so as the sun sets, those shades will stay visible longer because they can be bent further around the horizon. It's kind of weird to think about, but basically the red image of the sun sets first, followed by orange, yellow, and so on. There's a second or two delay between the last visible red sunlight and the violet. It's not a lot of time, but it's enough if you know when and where to look. And it works exactly in the opposite direction too with sunrises. But if the blue and violet shades of the sun are also above the horizon, why are these flashes green? Well, shorter wavelengths of light are scattered more after colliding with molecules in the air. That's why the sky is blue. But that also means violet and blue light are more likely to be scattered away from your line of sight, so you see the sun is green. If the air is super clear, though, you can see blue flashes. And if it's super hazy, enough green might be scattered to make the flash look yellow instead. But there's a reason you don't see a flash with every sunrise and sunset. By itself, this refraction isn't enough for you to actually be able to see the flash with your own eyeballs. The physical separation between the different colors isn't large enough, so we also need a mirage to magnify the effect. Mirages are just multiple images formed by atmospheric refraction. You might think one of those images is real and the rest are fake, but that's not the case. They all come from a single source. The mirage in this case looks like a second sun. You know those pictures of sunsets where it looks like the sun grows a little stand at the bottom? That's actually two mirage images overlapping, and it's what allows us to see green flashes. And during sunsets, there's also a physiological component that can amplify amplify the effect. When you look at a reddish sunset, the receptors in your eyes that detect red light get so used to being activated that when the source goes away, everything looks more green than it really is. But this doesn't happen in sunrises because there's no red sun to look at. The green rises above the horizon first. While green flashes can theoretically be seen anywhere on Earth at any time of year, they're best spotted above an unobscured horizon where the air is clean and relatively stable, which is probably why so many stories of them come from people on boats. So, if you find the right spot, you might just get a glimpse of what Jules Verne described as the true green of hope. Thanks for watching this episode of SciShow. If you love science as much as Jules Verne apparently loved the green sun, well, you've come to the right place. And if you want a new video every day, just go to youtube.com/SciShow and subscribe.
All right, so hopefully you guys got a little bit there. Now relate that back to what we just did with the prisms in class, and you saw with the refraction of the different colors, and different colors in Roy G. Biv, you have different wavelengths. So hopefully you got that out of class today, and we're going to build on that tomorrow, and hopefully we'll figure out which ones have longer wavelengths, shorter wavelengths, what a wavelength really is. So have a great Tuesday. Later.